Lesson 1, the magic formula for proportions. Before we learn the magic formula, let's go ahead and find out why proportions matter. So here, I have a picture of myself during my first ski trip in college. And it's a little small, but it's small on purpose. We're going to use it to illustrate a point. So let me make the picture a little bigger so that you can see. And here you can see that the picture is getting bigger, but it doesn't quite look right. It's a lot narrower than it should be. So let me undo that, and I'll try again a different way. What if I stretch it this way? And again, the picture's getting bigger, but it still doesn't look right. Now it's a lot wider than it should be. So I'll undo that. And here in the inspector, I'll click on Constrain Proportions. And this time, instead of making the picture only taller or only wider, I'm going to make it both taller and wider at the same time, at the same rate. And let's see what difference that makes. So I'll stretch it here from the corner. And as you can see, this looks a whole lot better. This is how the picture is supposed to look, and it's not distorted like it was the other two times. And this is what proportions are all about. It's about keeping things similar to each other without distorting them. So let's go back to our little photo, and let's suppose I make a copy and stretch it properly, just like this. And as you can see, these two photos are proportional to each other. You can tell because it's not distorted. And this is where understanding proportions is really helpful. Let's say the first photo is 1 unit tall and 2 units wide. Here's the second photo, and it's 3 units tall. Now, stop and think, and without actually measuring, can you figure out how wide the picture is? Let me give you a couple of seconds to think. And when kids see this example, most of them know intuitively that the photo is 1, 2, 3, 4, 5, 6 units wide. And that's the right answer, but the more important question is, how did you know that? A student might say, the smaller photo is 1 unit tall, and the larger photo is 3 units tall. That makes it 3 times taller than the smaller photo. And if it's 3 times taller, it must be 3 times wider as well. So since the smaller photo is 2 units wide, and the larger photo is 3 times as wide, 3 times 2 gives you 6 units. So that's how proportions are so helpful. If you have partial information about a problem, you can use what you know about the relationships in the problem to figure out the missing information. So let's go ahead and learn how to do that. Here's lesson 1, the magic formula for proportions. And notice that we have a smaller box and a larger box, and these represent the smaller photo and the larger photo from the demo. Keep in mind that these two boxes are proportional to each other. And we knew that in the smaller photo, it was 1 unit tall and 2 units wide. In the larger photo, we knew that it was 3 units tall, and we needed to figure out how wide it was without actually counting. So in order to solve a proportion, we need the magic formula, and here it is. Just write down A over B equals A over B. And that's it. That's the magic formula for proportions. Notice how simple it is, and I'll explain to students, if you can remember this one little formula, you'll be able to set up any proportion correctly, and you'll be able to solve it. A lot of times, kids struggle with proportions simply because they don't know how to set it up correctly. However, if you use the magic formula, you'll always be able to set up a proportion correctly. Then it becomes a simple matter of solving an equivalent fraction. Let's use the magic formula to defend our answer from the demo. So here, let's rewrite the magic formula. A over B equals A over B. And looking at the smaller box, we'll call the left side side A. And across the top, we'll call this side B. Now look at the larger box. The left side, we'll also call this side A. And across the top, this is side B. Now we just put in the numbers where they belong. So here in the smaller box, side A was 1 unit tall. So right here, I'll write down 1. And side B was 2 units wide. So right next to the B, I'll write down 2. Now for the larger box. Here, side A was 3 units tall, so I'll write it down. And side B was the side that we had to figure out. When you have a proportion, you have 4 numbers. And if 3 of them are given to you, you can use what you know about the relationships between them to figure out that 4th number. So here we have an equivalent fraction. How did you get from 1 to 3? And we got there by multiplying by 3. So I'll write times 3. And whatever you do to the top of a fraction, to the numerator, you also have to do the same thing on the bottom to the denominator. So write down times 3. 1 times 3 gives you that 3. 2 times 3 gives you the 6. Circle it. And let's see if this is true. Here in side B, we have 1, 2, 3, 4, 5, 6 units. And we know that our answer is correct. And that's how easy it is to solve proportions. Use the magic formula to set up the problem correctly, then it just becomes a matter of solving an equivalent fraction.